Okay, so just a quick reminder here at the beginning of our notes, don't forget about those extraneous solutions. And you kind of know when you should check for extraneous solutions because those are the types of functions that had restrictions to domain. So we have restriction to domain when we have a fraction because our denominator can't equal 0. Back in chapter 6, we had restrictions to domain for logarithms, so we always had to check for extraneous solutions with a logarithm. Couldn't take logs of 0 or negatives. And we also had to check extraneous solutions way back in semester 1. The first time we learned about them was with radical functions. If you have an even root, a negative underneath the even root can cause some trouble, so we had to check for extraneous solutions then. Okay. So we're checking today again to make sure that our denominators don't equal 0. Now, if we went into an Algebra 1 class and we showed them this equation on the board, I have a question over there on the other side. What would be intimidating to someone in Algebra 1 and maybe even in Algebra 2 about this particular equation? The fact that it has fractions in it, right? We just don't like the look of fractions. It makes problems look way more difficult, So I totally agree. Okay, now, hopefully in Algebra 1, they have maybe approached this kind of problem with those students before where, notice, all the fractions have a denominator of 2. So one way to solve this problem, this is like basic, you're going to do problems that are different than this, but one way to solve this problem is just to multiply the whole equation by 2. So I'm going to put a big set of parentheses around this equation and just say multiply everything by 2 because then 2 over 2 will cancel. So I'm distributing it to this first fraction, and then my denominator goes away. It's just x plus 4. And I'm distributing it to the second fraction, so it eliminates that denominator, and I get x squared minus 5x plus 8. And then I have an equal sign, and I have to multiply the 9/2 by 2, and I just get 9. Everybody okay with that? It's just going to cancel out all the 2's because I got to multiply the whole equation, all parts, all terms, all sides. Well, now it doesn't look like as terrible of an equation. That looks like something we could solve. It has x squared and x in it, so I'm going to be thinking about potentially factoring a quadratic formula. I would, of course, group my like terms, make one side equal to 0. Plus 3, right? And do you have factors of 3 that would combine to make negative 4? Negative 3 and negative 1. Oops. So x equals 3 and x equals 1. Now, you might have already solved a problem like that in Algebra 1. You never had to check for extraneous solutions in that particular problem because your denominators were all 2 constants, yeah. So it didn't matter what x was not going to make your denominator equal 0. So there was really no issue with that. Okay? So think about this like if you were going into, work with an Algebra 1 student, tutor an Algebra 1 student, help an Algebra 1 student, and they're really intimidated by the fact that the equation had fractions in it. Well, you could get rid of fractions by multiplying by that denominator. So we'll get another example, a quick one, easy. Okay. But what have I changed about this equation with fractions in it? The denominators are now different. They're no longer the same. So my question to you is, could we use that same method? Is there something that we could multiply by that would make our denominators cancel out so they don't look like fractions anymore? Yeah, multiply them together. It's I would call that in this particular case with fractions the least common denominator, right? It's the smallest number that has both factors in it. 2 times 3 is 6. Okay, so yeah, I would say that's the LCD. So I'll write that off to the side because you're going to see me write LCD down today. The LCD is 6. So I could really take the whole equation multiplied by 6. In this case, I'm just going to multiply every single part by 6 separately. That way, as I'm working the problem, when I multiply by 6, what happens to 6 over 2? It's just 3. And what happens to 6 over 3? It's just 2. And what happens to this 6 over 2? It's just 3 over 1, right? So like now we don't have denominators anymore. I should just do 5 times 3 is 15 plus 2x equals 3x squared. Could you solve that equation?
Yes.
Yeah. Well, you've got an x squared and an x. So you want one side set equal to 0. 0 equals 3x squared minus 2x minus 15. Try to factor or quadratic formula if you can't factor. Let's see, can we factor it? Factors of 45, negative 45. I don't think this one factors, so we would have to do quadratic formula. What's negative 15? Yeah, but because of the a, you'd have to have factors of negative 45 that adds to make negative 2. And there aren't any. 5 and 9 make 45, 3 and 15, but they're too far away. So we would have to do quadratic formula, but I'm not going to take the time to do it on this problem. Okay, so, but are you getting the drift here? What looks really intimidating about these problems is the fact that they have fractions. Well, let's eliminate that whole issue by multiplying by something that eliminates the denominator. Then we don't have to worry about fractions anymore. Everything's back on the regular line of text. Okay, so now we're going to apply it to what an Algebra 2 student would do. Okay. If you have a fraction plus or minus another fraction, and it equals a fraction, and like some of them could be non-fractions, then you're going to use what we call the LCD method. So that kind of goes back to what Mason was talking about when we said what number would we multiply by? We're going to find the least common denominator. So this means like if one side has plus or minus, you can't cross multiply. In order to cross multiply, it has to be fraction equals fraction. So what we're going to do is we're going to eliminate fractions, which is essentially what cross multiply does for you from yesterday. Okay. LCD method, factor denominators. That goes back to that question that Abby asked about on your homework number 8. You won't be able to see the least common denominator until you've made sure that they don't already have any factors in common. So make sure they're factored. Okay. Find the LCD. And then multiply the whole equation by the LCD. I'm a student learning about the LCD method. I want to know why I'm doing this. So that's the piece that I have there in red. If you multiply the whole equation by your least common denominator for all the fractions that appear in the equation, then you will no longer have any fractions and it will be a much easier equation to solve. So if you multiply by the LCD and you still have stuff that looks for like fractions, then you probably didn't find the actual LCD. If you choose a common denominator and not the least common denominator, it is possible to still solve it, but it requires more work. So choosing the least common denominator is working smarter, not harder. All right, let's do an example like you'll be seeing today. 5 over x plus 7 over 4 equals, that's a negative 9 over x. Don't miss that negative. Okay, notice the change here because we're in Algebra 2 and we're studying the rational equations and functions. Now my denominators aren't all numbers. There's variables down there. But the idea is still the same. I'd really like it to not look like fractions. So what's my LCD? 4x. So I'm going to multiply the whole equation by 4x, which is every single term. So I'm going to say times 4x times 4x times 4x. That would be me multiplying the whole equation by 4x, distribute to all terms, now I can cancel out the denominators. X cancels x. 5 times 4 is 20. 4 cancels 4, plus 7x. X cancels x, that's a negative 36. It's the same equation, but it looks a lot easier to solve, right? Any Algebra 1 student we give this equation to is going to be like, yep, I can solve that. So subtract 20 from both sides and divide by 7. So x equals negative 8. What should you do with your answer? Check it. Make sure that if you plug it into the denominators where x is, you're not going to get a 0. Are we okay? Yep. Okay. So we're using the LCD to get rid of fractions and make that blue equation that looks really easy to solve. Thanks, Luke. Okay. Let's do this one. 1 minus 8 over x minus 5 equals 3 over x. Okay, so you'll have to pay attention. You can't just cross multiply these two fractions because then, like, what are you doing with that 1 over there, right? So what we want to do is we want to make it an equation that doesn't have fractions anymore. What's your LCD? Okay, what's the denominator for this one?
1.
It's really over 1. What's the factor in this denominator? X minus 5. So we have to have a factor of x minus 5 in our LCD. What's the factor in that denominator? X. So we also have to have a factor of x. This x in x minus 5 is not a factor of x. It's a term because it's being added with 5 or subtracted. So our LCD is made up of the two factors, x times x minus 5. Now when I'm doing my LCD method, I never multiply that out. I don't write that as x squared minus 5x because I might only want to cancel one part of it. So now I'm going to take that whole LCD and I'm going to multiply x times x minus 5, x times x minus 5, x times x minus 5. Good news is some things are going to cancel. In this one, nothing cancels. So I'll have what? X squared minus 5x. Here I'll be able to cancel out x minus 5. Now pay attention, this is a minus 8x now. And on the other side I can cancel x. So I just have to distribute the 3. So that's equal to 3x minus 15. Doesn't this blue line look a lot more solvable than the line with all the fractions? Yeah. So you're just kind of playing a game of making your denominators disappear. That's called the LCD method. Okay, I would combine my like terms. X squared minus 13x equals 3x minus 15. Of course, I have an x squared and an x, so I need one side to equal 0. So I'm going to subtract 3x, that's minus 16x, and add 15, that's plus 15. Do you have factors of 15 that combine to make negative 16? Sure, x minus 15 and x minus 1. So then x equals 15 and 1. Okay. What should you do with both of those answers? Plug them in. Do either of those values, 15 or 1, make your original denominators equal 0? Nope. So both good answers. Okay, does anybody have any questions they want to break in and ask right now? Okay. We'll do this one for sure. Then you can let me know if you're ready for your homework. 6 over x minus 3 equals 8x squared over x squared minus 9 minus 4x over x plus 3. Now, look at your denominators. What do you notice?
You can factor out x squared minus 9.
Yeah, you want to look for any denominators that can be factored. Because x squared minus 9 is really x minus 3, x plus 3. So I'm going to cross off x squared minus 9 and replace it with x minus 3, x plus 3. Which means that my LCD is x minus 3, x plus 3. And that's a lot easier than using a common denominator of x minus 3, x plus 3, x squared minus 9. You're going to have a much bigger polynomial to work with if you use that. So take both factors and multiply every single term. X plus 3x minus 3, x plus 3x minus 3, x plus 3x minus 3. Cancel out the ones that appear in the numerator and the denominator now. So I can cancel out x minus 3. Distribute my 6. I have 6x plus 18. Equals, yeah, 8x squared. I gotta cancel out all of that. I'm sorry, I wrote over my squared there, but it's 8x squared left over. That's nice when you cancel out the whole denominator. Love that. Just left with the numerator. And then on the last one, cancel the x plus 3's. Now remember, this is a negative 4x. So when I distribute, I'm going to get, what, minus 4x squared and plus 12x. So you'll have to watch your signs if you've got subtraction. And again, giving someone in Algebra 2 or Algebra 1 this very first equation with all the fractions can look intimidating. If you use the LCD to eliminate the fractions, doesn't this look like something you'd be willing to solve? Combine like terms. Get everything on one side because you have x squared and x's. I always like to keep my x squared positive, so I'm going to move everything to the right. So that's going to be 4x squared plus 6x minus 18. And you would have options, try factoring or quadratic formula. In terms of factoring, I noticed 4, 6, and 18 all share a common factor of 2. So I can take out that 2, 2x squared plus 3x minus 9. You heard me do this for that one where I said we would have to use quadratic formula, but if you ever want to know if it even factors, if it's got something other than a 1, take your a, 2, multiply it by your c, -9, which is -18. Do you have factors of -18 that combine to make 3? Yeah, so then it means it is factorable. It doesn't mean those are the factors, -6 and 3, or sorry, 6 and -3, but it does mean that it factors. Okay. So we would do, I use guess and check, 2x and x. What are some factors of 9? 3 and 3, right? And think about it. If you put 3 and 3 in, then your outside is going to be 6 and your inside is going to be 3, which are those factors of 18. Okay, so we'll put 3 and 3. We're going to be positive 3, so we'll have to do plus and minus. So a bigger number is positive. So when I FOIL this out, I would get 2x squared. I would get -9, and then my outsides with my fingers, 2x times 3 is positive 6x. -3 times x is -3x, and that makes the positive 3x that I want. What are my answers? X equals 3 over 2 and -3. Check both of those. -3 does not work. It makes your denominator equal 0. So cross it off and call it extraneous. Okay, Hannah.
Where did you get the 3 over 2 from?
2x minus 3 equals 0. Add 3. Divide by 2. Any other questions? Okay, would you like some time to work on the assignment? Okay, so I will pass that out.